Today is our last part of notes for section 2, and we're going to practice naming ionic compounds, covalent compounds, and acids. So the hard part about today is that we're going to kind of jumble them all together. So we don't know ahead of time if it's an ionic compound, covalent compound, or if it's an acid. So if we're given the names, we'll come up with the formulas. If we're given the formulas, we'll come up with the names. All right, so let's get started. So practice with naming ionic compounds, covalent compounds, and acids. Example, and there'll be a whole bunch of them. Name the following mixed assortment of compounds and state whether that compound is ionic or covalent, or if it's an acid. All right? So, A, HC2H3O2. Notice that it starts with an H. There's a heads up. B, NH4NO2. C, ICL. D, CO2S3. So for A, we notice that it starts with an H. Okay, so that makes us think, okay, this is an acid. And then we'd have to have it memorized from that list I gave you that it's acetic acid. That list was in one of our previous videos. NH4NO2, what I see is I see two chunks, right? I see a chunk of NH4 and a chunk of NO2. That makes me think, well, these are polyatomic ions, so it must be an ionic compound. So splitting into ions certainly helps, and we come up with ammonium nitrite. Okay, C, ICL. The first thing I notice is that I and Cl are both to the right of the staircase. These are both nonmetals. So this must be a molecular compound or a covalent compound, synonymous terms. So it's iodine monochloride. D, CO2S3. First thing I recognize is that cobalt is a metal. Boom, metal. Ionic compound. I can use the reverse crossover. So the 2's and the 3's come back up. And that's how we get the charge of cobalt 3 sulfide. Remember, we can't just name it cobalt sulfide. So we have to get that plus 3 by taking the S3 coming back up. All right. Now, you notice that CO2S3 is not dicobalt trisulfide, all right? Because it's not a covalent compound. It's not a molecular compound, right? It's ionic. We didn't use any prefixes until we got to naming covalent compounds. So that's the hang up when we do this mixed assortment of compounds. Is sometimes we get our rules mixed up, so that's why we're practicing today on stuff that we've already gone over. Okay, so we've done A, B, C, and D. And we're making note again down here that cobalt is a metal. And it's in ionic compounds, so there's no prefixes. All right, so let's do some more. E is PB3PO42, F KIO3, G H2SO4, starts with an H. H is SR3N2, and I P2O5. So if we go up to E, I notice it's an ionic compound. How come? Well, I see that chunk of phosphate, which I know is a polyatomic ion, plus I'm aware that lead is a metal. These are both things we find in ionic compounds. I do the reverse crossover in order to figure out that this is lead Roman numeral 2 phosphate. KIO3. First thing I recognize, for me anyway, is that IO3 is a chunk. It's a polyatomic ion. This will be an ionic compound. Also, potassium is a group 1 metal. This is potassium iodate. It's not potassium Roman numeral 1 because I don't need it. Potassium is group 1, always a +1. G, H2SO4, it's an acid, sulfuric acid. H, strontium, group 2 metal. It's always a +2. So this is a metal, non-metal pair. This is what we see with ionic compounds. So what's the name of this? Well, it's not strontium Roman numeral 2 because strontium's always a +2. So it's strontium nitride. All right, I, P2O5. These are both nonmetals. Okay, P and O are both nonmetals. They're both to the right of the staircase on the periodic table. Non-metal pair is a molecular compound or a covalent compound, whichever you prefer. So we have to use prefixes for molecular compounds. So this is diphosphorus pentoxide. All right, even more examples to help hammer this home. Naming is very, very important. So we have a bunch more here. JSNO2. Well, tin is a metal. Okay, so we have to figure out the charge of tin. You can't just call it tin oxide because tin can have multiple charges. It's one of those transition metals that can have multiple charges. So I need to set it all up. And what I come up with is that oxide is always a -2. And there's 2 of them here for a total of -4. That means my 1 tin must be a +4 charge. All right, this is tin Roman numeral 4 oxide. This is one of the very few times that the reverse crossover won't work because really the way this started out was SN2O4. And the reverse crossover, it's because it's been reduced. But long story short, it's tin Roman numeral 4 oxide. K, Al2SO3, 3. Well, aluminum is a metal, so we know this is ionic. And aluminum is always a +3. Okay, so we just have to call it aluminum sulfide. Aluminum is always a +3. All right, next example, we're going to go the other way around. It says for each compound, write the correct chemical formula. All right, so now we're going to be given the names and we have to come up with the formulas. A, sulfur hexabromide. B, lithium nitride. So in A, sulfur hexabromide, I see the prefix hexa. I know it's a covalent compound and I can just sound it out. So the hexa makes me think 6. Sulfur hexabromide is SBr6. All right, for B, lithium nitride. Lithium is a metal, so this is ionic. I can draw the charges next to each other and then cross those charges over and reduce if necessary. Li +1, N -3, cross over the +1 and the 3. I come up with Li3N once I clean it up. All right, crossover method is for ionic compounds. All right, next page of notes here we have C, chromium, Roman numeral 3, carbonate. Well, I already know it's a metal there with the chromium 3, don't I? Same thing down here in D with tin 2. E, ammonium acetate. F is potassium hydride. G, cobalt, Roman numeral 3, nitrate. H, hydroselenic acid, gives us the name acid, which is nice. I, mercury, Roman numeral 1, chloride. Okay, so let's start from the top. Chromium 3 carbonate. I recognize that chromium 3 means this is an ionic compound. Cr3+, carbonate is CO3 with a 2-, that chunk. Cross over the 3 and the 2's, clean it up, we come up with Cr2, CO3, 3. Tin 2 fluoride, same thing. We write Sn +2, F is always a -1. Cross them over, come up with SnF2. E, ammonium acetate. Ammonium is a chunk, NH4 plus 1. Acetate is a chunk, C2H3O2 minus. Ones and ones come down. This is a nice clean NH4 C2H3O2. You do not use a parentheses if there's only one of them. That's why you don't see parentheses around C2H3O2. F, potassium hydride. Well, potassium is a metal, K plus 1. Hydride, written as an anion, is strange, H minus 1. First time we've seen that in our notes, so just be aware of it. It's KH. G, cobalt-3 nitrate, CONO3 when you use your crossover rules. H, hydroselenic acid. You'd have to have this memorized. It's H2SE. Mercury 1 chloride. Now, Mercury 1 is that special one. It's that dimer. This is Mercury 1 is Hg2, the whole thing being a 2 plus charge. And then chloride, group 17 halogen. These guys always like to be a -1. We need 2 of those to get a total of -2. So this is Hg2Cl2. Now I mentioned briefly, let's put it in our notes here. Mercury 1 is a dimer of 2 fused Hg plus 1 ions. That's why it looks strange. We made note of that in our list of polyatomic ions. And then we cannot reduce the subscript 2's there. Why not? Well, we have a Mercury 1 ion involved, so we have to keep it as Hg2Cl2. Alright? Alright, so that's it for section 2. The next notes we're going to do is on section 3, and that's when we start talking about molar mass, going from moles to moles, mass to moles, mass to mass, moles to molecules, etc. So that'll be the stoichiometry section. It's a really important section. Is section 3. So please subscribe to my channel, and you'll be made aware of when I start posting on section 3, and then all the other sections. General chemistry goes all the way up to section 20. So you can expect a lot more videos coming. Anyway, thank you very much. Bye.